Okay, so in the last video, we created a closure. So let's recap. We had a nested function inside of another function. So in this example, we had the welcome function defined inside of the greeting function. We had the welcome function inside its code body referencing a value that was defined in the enclosing function. In this example, it was the variable message. And finally, the enclosing function returned the nested function. In other words, the greeting function returned the nested function called welcome. We then created a new variable called new_name and set this equal to a call on the greeting function. Now, what does this piece of syntax here remind you of? Well, when we create classes, we create an instance of that class by writing very similar syntax. So closures can also be seen to provide an object-oriented solution to a problem that you may face. Now you may be thinking, well, when do I use classes and then when should I use closures? Now when you have a method or a couple of methods to be implemented in a class, closures can provide an alternative solution and a more elegant solution to the problem you may face. But when the number of attributes and methods that you want defined get larger and larger, it's better to store this in a class. So let me show you a simple example where a closure might be more preferable than defining a class and then creating instances of that class separately. Now obviously when it comes to development, you are the developer, you get the choice at the end of the day, but hopefully this gives you an idea as to when closures may be preferred over creating a class. So for this example, I'm going to create a function that enables easy multiplication of two numbers. So to do this, I'm first of all going to define an outer enclosing function which we're going to call base_multiple. We're then going to pass in one parameter name labelled base. I'm then going to put a colon. The second thing we need to do is create a nested function, so I'm going to put def, and the nested function will be called multiply_by. I will then pass in one parameter name which we'll label as x. I then want the function to perform the calculation, so I'm going to return base multiplied by x, and then I'm simply going to return the nested function's name, so I'm going to return multiply_by. Great, so we've now created our closure. We can now create a new object name, and let's suppose that we want a function that deals with multiples of 8. So to do this, I can create a new name called multiply_by_8, and I can set this equal to a call on the function base_multiple, and inside parentheses here, I can pass in that base number 8. Now, because the multiply_by_8 name is bound to what is returned, which in this case is the return on the multiply_by function, I'm now able to call upon the multiply_by_8 name that will then perform the calculation accordingly. So if I now print to the screen, multiply by 8, and then in brackets pass in 10, you can see that I get 80 returned to the screen. If I call this name again, but this time pass in 12, you can see we get 96 returned. So we've now essentially created ourselves an object that we can use that will always handle multiplications by 8. Using the same closure, let's create another instance which deals with multiplications by 15. So multiply_by_15 can be the name. We can set this equal to base_multiple and then pass in the number 15. I can now call upon my new name, so multiply_by_15, and in brackets I can pass in 2. When I run this code cell, we print 30 to the screen. And let's say we were interested in what 15 times 15 was. If I call upon multiply by 15 and pass in 15 to the parentheses, you can see we return 225. So we've been able to create a closure which returns that multiply_by function, and I can then create a new name which is a call on the outer function which returns the nested function, and then I can use this name whenever I want to in my code. Now, why am I showing you all of this? Well, Python decorators make extensive use of closures. And you're going to see a lot of familiar syntax that I've just shown you when we discuss decorators. So hopefully you've managed to follow along with some of these concepts, as they will certainly help in subsequent tutorials. In the next video, let's get back into decorators.